Hi, I'm Antonio Sala. In this video, we'll discuss coprime factor uncertainty to try to get an intuitive understanding of the distance between two plants in the so-called Winnicombe's NuGap metric. We'll just concentrate on the simplest case, real numbers, single input, single output, to better grasp the intuition of the underlying concepts. The basic idea is that I can obtain the robustness of a control loop with respect to uncertainty in the plant P in the normalized coprime factor representation. So this is P, and roughly in the real case will be that n squared plus d squared is 1. Of course, in the complex cases, conjugate transposed and things like that. So this thing is the maximum size this delta n and delta d normalized can have. If we are thinking in, transfer function matrices, the concept seems kind of very abstract and impractical, hard to understand at first glance. So in order to better grasp the idea on what's this all about, we will just assume, for instance, that let's say numerator is 3, denominator is 4, so P is 0.75, so we'll try to understand the meaning with this simple example. Of course, if you have a good mathematical background, then you can just read Winnicombe's book or papers, and you can understand in one shot the most complex version of these ideas. But okay, as you know, working with 3 and 4 seems simpler than working with a full transfer function matrix with complex numbers in the frequency domain, and same for the denominator. We'll just stick to the real case to grasp the geometric meaning of this coprime factor uncertainty. Let's go. We will have a number represented as a fraction, numerator divided by denominator with, of course, non-zero denominator. So the number 0.75, well, as we can express it as 0.75 divided by 1, then we can express it as this fraction, numerator 0.75, denominator 1, or of course that's equivalent. We will write this equivalence relation between these two pairs of numbers, which we will understand that as numerator and denominator, if of course the quotient is the same. They represent the same number. So this pair of numbers in R2, well, actually R2 accepting, 0n. Well, the thing is that 0.75, which is this fraction, is of course equivalent to 3 divided by 4, or 9 divided by 12, or let's say anything is this line. If I multiply these two numbers by the same factor, q, then I get the line in the plane that we are discussing. But of course, all the points in this line represent, with this kind of equivalence relation, the same real number, 0.75. So the real number is actually the slope, the tangent of this angle, say gamma, of the line. But between all the possible points in the plane that represent the number 0.75, the one that intersects with the unit circle, unit circumference, center at 0, radius 1, will be this one. This one here, in our particular example. You can check that indeed this thing square plus this thing square gives 1. So this is the normalized representation of that number. In general, any real number P1 can be interpreted as the fraction P1 divided by 1, this pair of numerator and denominator 1. And if I divide everything by square root of 1 plus P1 squared, then the sum of the squares of these two components is 1. So we will have the normalized representation of the number P1. So any real number can be mapped to a point in this right half circle. Of course, there is a point in the other end that is also normalized. Okay, there are two of them because we can have the signs of the square root, but we will map everything on the right half, the open right half of the circle. The north pole here will be, say, plus infinity, and the south pole will be minus infinity. So this is the geometrical meaning of the coprime factorization. Of course, in the real case, the complex and matrix stuff, it's not the objective of these materials because we want to illustrate the simplest version of a very complicated idea. So once we have this understanding of what the normalized factorization is, then we can have two numbers, P1 and P2, represented by these two lines, and then we want to measure the distance between them as follows. We have P1, we have P2, but we will understand P1 as the normalized fraction representing P1 here, the green star, and the red star, the normalized representation of P2. Then we will understand P1, this number, as let's say the nominal value of the plant, and P2 may be the disturbed P1 plus some delta. Of course, that delta, if we need to understand that uncertainty in the language of uncertainty over the normalized coprime factorization, then we need to understand that delta as something that it's added to the normalized components n1 d1 to get n1 plus delta n d1 plus delta d. And this new fraction must be equal to P2, d2 and 2, but okay, not equal. We need only to be equivalent. We need only to be a new numerator and denominator that lies in this line, which represents all the fractions equivalent to real number P2. So, which is the smallest delta d delta n that can be added to d1 and 1 and get something in the bottom line? Well, this is it. If I add this vector, its components will be delta d delta n, and I will land on the bottom line equivalent to P2. This increment is just the minimum distance between the green star and the red line. This is orthogonal, and so this is the main result. The smallest perturbation to the green star, the smallest in Euclidean norm, such that I transform P1 onto P2 is the distance of this segment, and that will be called the nu gap between P1 and P2, the norm of this vector that, well, as this is radius 1, if alpha is the angle between the two lines that represent P1 and P2, then the length of this segment is the sine of alpha. So this is it. Let us summarize to conclude. Any real number can be understood as a line whose slope is the real number and the actual components are numerator and denominator of equivalent fractions. The normalized representation is the intersection of that line with the unit circumference, and the norm of the minimum deviation that converts P1 in P2 is the sine of the angle between the two lines. So the actual number represented is the tangent of the angles of each of the lines, and the nu gap, the normalized coprime factor uncertainty associated to the difference between P1 and P2 is the sinus of the angular difference between the lines. So this is it. We'll expand the idea in a subsequent video. We'll finish for now. Thanks for watching.